So thanks for the invitation. So today I'm going to talk about the system overview and the systematic analysis of the Taiwan Meteor Detection System. So my name is Zhong-Yi from the Institute of Astronomy National Center University Taiwan. So here is my collaboration from including Taiwan Astronomy Museum and the National Donghua University and the Kending Observatory. So I think sorry I can see my next. Okay, I think probably you know the optical the scientific object for the meter optical observation. The scientific goal is to control the meteor orbit to see where this meteor came from some part of the solar systems. And also you can use the meteor shower to compute their flux mass and mass index and the orbit to constrain the meteor shower and the prediction models. And also you can use the fireball to increase the number of the meteorite to know the orbit to constrain the meteor source of region. But however, because the Taiwan is surrounding the sea, so we might we might not get something like the falling rock or something the meteorites from the sea because it's difficult to from Taiwan point of view. And also the next we can observe the some prediction from the cometary outburst. For example, this is a tower wind from Taiwan. The next October from the David Clark. He 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 got some simulation for this cometary outburst, and then to see if our side our Taiwan meteor shower detect system can be detect this event or not. However, on that time our weather was not so good, so we did not get any results. So from the in the beginning of this Taiwan Meteor Detector System, this system was established in 2016. Why I call the established? Because in 2010 2012 there was one Professor Shinsuke Abe. He 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 was in NCU. He established the first Taiwan meteor shower detection system. But since he left from to Japan, the system did not well maintained. So from 2016, I want to do something for the undergraduate program, the training program. So I re-established this system. So first, in last 2 years, we only have a few stations to observe these meteors. So finally, in until 2023, we have we have a 5 station that that have good sky coverage to get more meteor and orbit. So you can see this is the station situation here. Okay, so based using the Lulin Observatory as the center of the Taiwan. So we look for the sky, the well coverage, the place, the location. Then we start to get to set up the system. So because this my I'm not familiar with this mutual study research, so I just use a very simple system, as you say. As you can see, this Watec camera with focus lens, and the grating. We have also have a grating to get the spectrum, as you see in lab figures. So we observe of course we try to observe all night and every night. Then the data can come up from the every station to the and download automatically to the our university. So as I say, this is a undergraduate students training program. So we make this the very simply because we own because the use they quite use the Windows system. So we use you have a software to calculate the orbiter and to calculate the sound velocity. But we want to training the student to use the Python script to analyze the data we collect from the result of this software. So this is our first publish. We introduce our system just in the very beginnings. But now we have about 30, almost 30 meteor detections and 6,000 orbits. But however, most of them are sporadic meteors. So as you can see, this is our the gray dot means sporadic meteors. Now, the other one is the meteor shower that you can see in these tables. So for the students trainings, we want to know they want to make, of course they want to make a comparison in between the INO and our results. For example, the radiant velocity and so on, and they quite, of course, they quite you because of our data. Because Germany meteor shower, the data is we got a lot of data of this measure. So students often study with this measure to get some results. As you can see, this is the velocity distribution, this is the magnitude distribution, this radiant drip of the Gemini meteor shower. So as you can see, the red dot is the average of the INO point, but there are some shoots, but probably because it is an observational bias. And we also want to know the orbital similarity for the parent body. So we let the students use this function to get some result of the DSH values. And the results of the facade also similar to the general meteor showers, but we added another orbital similarity for the DH. So this is the newest result until this August. And also we as you know that there's a new comet discovered in this August, and then there are some connections between the Sigma Hydrus meteor showers, because you can see this from the symbol EPC, and they talk about they probably some conventions. So we quickly do some orbital simulation, orbital similarity calculations. As you can see, it's quite the DHSH and the DH value is quite. I think it's quite look like similar. So we, besides this calculation, we also want to know as we say the mass index or population index. So this example for the Gemini meteor shower in 2021. So this is the summary, right? We got very similarity for this I mean the value between the published one, for example, the population index and the mass index, and also the DSH distributions. So that's all. So thank you for your attention.